My name is Megan McArthur. I'm the pilot for NASA's SpaceX Crew-2 mission to the International Space Station. I'm about to launch into space with 3 crewmates aboard the commercial vehicle called Crew-Dragon, built by SpaceX, and we're going to go to the International Space Station and stay for 6 months. In my role as the pilot, I help our commander, Shane Kimbrough, monitor the spacecraft systems during all phases of flight. Shane and I have been training together in simulators both in Houston and in Hawthorne, California, and we train the various scenarios of the flight. Initially, we start with just our instructor, who describes for us what's happening, what we should be monitoring, and how we respond to different failures that might happen. And then, as we learn more, then we train with the ground control team, and the simulator has more malfunctions that we have to respond to as a team. We have to communicate together and figure out what the next step is for our flight. So we go through kind of a graduated experience of sort of learning the basics and then making things more complicated as we go along. We do it in our regular street clothes, and then we also do scenarios where we're wearing the spacesuit so we can see what we can actually reach and access during all these different phases of flight. So comparing the Crew-Dragon with the space shuttle training, obviously the vehicles have a lot of differences, even though their goal is the same, to get people into low Earth orbit. And so with the space shuttles, built in the 1970s really, we had a lot of switches, like panels and panels of switches. And I remember when I first arrived thinking, there is no way I'm ever going to learn what all those switches do. But of course your instructors really break it down system by system, walk you through everything, teach you the basics, and then teach you how to respond to all the failures. With Crew-Dragon, of course, we don't have those panels and panels of switches. We have a very clean wall environment and some large touch screens where we can switch between monitoring different systems. We don't have the same interaction with the vehicle. We can't send as many commands to the Crew-Dragon as we could to Space Shuttle, but we have a team of ground controllers that send a lot of those commands and are monitoring in a way that we couldn't do with space shuttles back in the day. So it's very interesting to compare the two vehicles and the style of training that's required for the two vehicles. So training to live aboard the International Space Station, it's very different than training to do a short duration shuttle mission, which is what I have done in the past. For a shuttle mission, we were able to train every single task that we knew we were planning to do while we were in space. And we could train those tasks, those spacewalks, for example, those robotic activities over and over and over again, so we could get really good at those specific tasks. For Space Station, you're living in space for 6 months. So your training is very different. You can't possibly train every single task that you're going to do every day. There's just too much. And so we take a more skills-based approach where we, in general, learn how to operate the different systems, but not the specific tasks that we might be doing on any given day. So it's a very different style of training, and it requires a different approach. Yes, so for the shuttle mission, I went to help repair the Hubble Space Telescope, and so we had very specific spacewalks that we were going to do. I was the robotic arm operator, so I supported all of those spacewalks. I used the robotic arm to capture the telescope, and so I was able to train for those specific tasks very rigorously. And of course, things don't always go exactly as you plan, but because of your training, you're able to adapt to those situations. But I was, one of my main focuses was capturing this free-flying vehicle, the Hubble Space Telescope. Whereas for a station mission, capturing a free-flying cargo vehicle is just one of many things that I hope to get to do while I'm up there. So you have to take a kind of a different approach. You have a different mindset that is not, I need to understand every last detail. It has more to do with, I need to know where to find the information when I need it, and I need to know in general kind of the operational principles that are supporting these tasks. So we're doing hardware tasks, so we're maintaining the systems that keep the space station running, but we're also doing a lot of science. And it's science that you're not necessarily raised in as a professional. I'm not a biologist, and yet I might be doing a lot of human research on myself, basically, while I'm in space. And so, doing pipetting and those kinds of skills are sort of general skills that we've had to learn that are things, I didn't necessarily come up doing. Probably the last time I did it was in high school. And so we're having to learn these general tasks and how to do those basic skills very well, and then follow the procedures that the experts have written for us. That's right. This is a tremendously experienced crew that I get to fly with. I have 3 crewmates who have all flown on space station before, long duration. 2 of them have also done shuttle missions, and so it really helps for me bridge that gap. They can help me draw parallels and understand where things are going to be really different. So waking up on launch day it's such a great feeling that I remember from my previous flight. And kind of the big moments, you wake up, you get dressed, you go down, meet your crewmates for breakfast, and maybe you've requested a special favorite thing before you go. Then, of course, you're going to see the docs, talk to the docs one more time before you get ready. Then you're going to start getting into your undergarments, your long underwear that you wear under the suit. Usually there's a weather briefing fit in there somewhere, so you're talking with the larger team about how the weather looks for that day. And then you're getting suited up in the suit room. And you're there with all of your crewmates, you're doing pressure checks on your suit, and the excitement is really starting to build. One of the things that's really unique and new for us that we do now, when we do the walkout from the crew quarters and then go get into the transportation to take you out to the launch pad, now we have actually family members outside in a cheering section, which we didn't used to do for shuttle. And so I'm really looking forward to that. It was very fun to watch my husband do that. We got to cheer for him as he walked out. That was really special for my son and I. And so I'm looking forward to that experience on this day. And then, of course, you drive out to the launch pad as a crew with your entourage. Your entourage gets smaller the closer you get to the launch pad, of course. And then when you arrive there and you take that elevator up to the level where you're going to climb aboard, and then you go on board in order, and it's just you have your time waiting there while you're looking out over the beautiful Florida coast. It's a really exhilarating feeling getting ready to strap in. And then once you strap in, there's a lot of just waiting. And so you've had a lot of excitement, a lot of buildup, and then you get in, and then there's the waiting. So that part is it's probably good to kind of bring that excitement level back down again. But then of course then the countdown gets closer and closer, all in preparation for the launch. It is. It's amazing to think that I will be sitting in the same seat that Bob was sitting in when he certified that vehicle the very first time that it launched. I don't think I realized that when I found out that I was going to be assigned to the Crew-2 mission. I didn't realize it was going to be the same vehicle, but that certainly adds a little something special to the mission. It's interesting, I think it's going to be very different from shuttle, obviously. The parts of the flight that are smooth and the parts of the flight that are rough and what you can hear. But I also know that what's true is every launch experience is very unique to the individual, right? And it's very hard to describe it accurately, because in truth you kind of experience a sensory overload. What I have from my shuttle flight is a very clear visual memory of everything that I could see, and then the memory of talking back and forth with my crewmates. We had some failures right at launch, and so my memory of those conversations and what we could see is very clear. But when people ask me, well, how did it feel and what did the vehicle sound like? It's almost like those channels weren't written for me. I just, I was so focused on these other things that I was doing. And so it is a very individual experience, and unfortunately it's hard for someone who's not great with words. It's hard to really describe it accurately. We are so fortunate to have a great support team down here that provides us with regular communication with our families. So I will get to video chat with my family regularly. I can call them on the phone. I will have email access. And so I'm hopeful that people will send me lots of notes and pictures of what's going on in their regular lives. That's so important, I think, to kind of anchor us to what's going on, back at home. It's hard, of course, to respond, of course, to every single email that you get, but definitely being able to read them is going to be really important. And taking pictures of things, of places where the people I love live, that's going to be something important too, and a great way to stay connected. One of the things I learned when Bob was in space was it can be very difficult for a young child to participate, for a long time in a video chat. And so I think as the parent that's in space, you kind of have to temper your expectations, right? So as much as I think, I have these 30 minutes, I really want to talk with my husband and my son, it just might not be a great time for them. And so I think that was really my takeaway from Bob's experience, was that you kind of just have to go with the flow. And when your child is ready to talk to you, you just soak it up. And when he's not, you just have to not take it personally and look forward to the next time. So taking little videos, having someone take videos of what my son is doing and sending those to me will also be a really important thing. So we adopted a puppy in November. We got him from a local shelter, and our son named him Shadow because he's very dark, and it's a great name because he's always underfoot, especially in the kitchen. And so he's been a great addition to the family, and we're still growing together, and teaching him how to have good manners, and he's teaching us how to take good care of him. So that's been a lot of fun for us. So my parents are from a small town in Washington, and my dad joined the U.S. Navy out of college, and so our family life has been kind of a worldwide adventure. My parents, even though from a small town, they were very adventurous, and so we lived overseas in a couple of different places. We lived in Japan, we lived in England, and while we were in those places, our parents, always took every opportunity to get us out into, to see the sights and to see the beautiful places in those different countries. So I think that's kind of where my love for adventure and travel first came from. But it did mean that I went to a lot of different schools growing up. So it seemed like every year or two we were in a different place, going to a different school. I went to 3 different high schools. But eventually our family settled in California, so I would consider California as kind of my home state. I went to university in California, in Southern California. I went to UCLA for my undergraduate work, and I studied aerospace engineering there. And I got involved with a group of friends who were doing an engineering project called the Human-Powered Submarine Races. And so we got a lot of teasing for being a bunch of aerospace engineers that were building a submarine, but it was a great project. It was a great hands-on experience, and how you budget for something, and how you actually design and build something, and then how you operate it. And so that was a tremendous experience, and it got me interested in the oceans. I ended up being the pilot for the submarine, and partly because I was the only one who would fit in the pilot space. And so I had to get scuba certified and spend a lot of time in the water. And so that was it was in a lot of ways a life-changing experience for me. I fell in love with the oceans, with the idea of exploring the oceans. And so I took a little bit of a left turn and studied oceanography at the Scripps Institution of Oceanography in San Diego. And so I spent about 6 years there, earning a PhD and doing some ocean-going research for that work. And then from there, I got hired. I applied and got hired to be an astronaut from graduate school. Then I've been here ever since then. So I first thought of becoming an astronaut when I was in high school. So my dad was a Navy pilot, and so we lived on military bases where there was lots of aircraft. He took us to lots of air shows growing up, and so I first thought, I'd love to be a pilot. And then as I got a little bit older, we lived at Ames Research Center, or we lived at Moffett Field Naval Air Station, which was connected with Ames Research Center, and there was a lot of aviation research that went on there. We'd hear the wind tunnels going, at all hours of the day and night. And also it's where the vertical motion simulator is, where shuttle astronauts would come to do their landing and rollout training. And so I would see them, come in their T-38 jets and get out in their spiffy blue flight suits and walk in to do their training. And I thought, well, that looks like fun. How do I get that job? And I knew that it was a long shot, right? But I also knew that I wanted to be a part of something like that, right? A part of this bigger thing of exploration. And so I started looking into, what kind of degrees do people have and what kind of work do people do? And I had the opportunity to do an internship there at Ames when I was in college. And so that's where the idea first came from, was just, hey, I want to be a part of this. And then I kind of took this left turn into oceanography, and people think, well, that's kind of weird. You're interested in space, now you're interested in the oceans. But really, it's all about exploration, right? So we're not better equipped to survive underwater, any better than we are in outer space. And so we need technology to help us explore those areas. So how do we do those things? We can send rovers, we can send people, we have to build the right kind of machines to support that. And so there's a lot of parallels. When you go out on a ship at sea, you need to have all the equipment you need. If something breaks, you need to be able to fix it. There's a lot of similar operational principles, if you will. So that's kind of how I tell it to myself, that it still made sense that I still wanted to be an astronaut. So from graduate school in oceanography, I always had this idea in the back of my mind, and I went ahead and applied, and I got really lucky. I love working as a Capcom. I think it's one of the best jobs that we have. Next to flying in space, you are a part of the team that is helping fly in space, the flight director and that whole team that's running the spaceship, and you're right there as the voice of that room. So you're representing the crew, you're representing the controllers on the ground, you're that point of contact between both, and so you're really right in the middle, and it's a lot of fun. It's a great way to learn, and it's really a lot of fun. I remember training with Aki as Capcom. I do remember that, yeah. I was a Capcom a lot, and so I have trained a lot of Capcoms. So the launch for STS-125 was very unique because we were not going to the International Space Station. And this was in the years following the Columbia accident, and the safe haven for all of the space shuttles after that accident was to be able to stay aboard the International Space Station until another vehicle could be readied. So in order for us to do this mission, to go to the Hubble Space Telescope, there had to actually be another space shuttle on another launch pad that was within a week of coming to get us if we had a problem with the thermal protection system on our space shuttle. So this was a very unique situation. You know, driving out to the launch pad, you see two space shuttles, not quite side by side, but you could have them both in your view, and our commander joked with the driver, like, make sure you take us to the correct vehicle that's launching today. So that was very interesting. It was a tremendously fun crew. It's a great group of folks. There were 7 of us. And we climbed aboard, and again, there's that period of waiting where you're really hoping that this is going to go soon and that the weather's not going to bite you. You actually get a little bit uncomfortable. Your body starts to cramp up, and you're ready to go. And then when the actual launch goes, it really is, it's indescribable. It's so much energy. You are moving so fast, and we got right at liftoff. We got a master alarm, which is a very alarming sound, as you might expect. And you hear it all the time in simulation, but you're not really expecting it to happen on the launch day. But your training works really well because we saw the message. We knew immediately that we didn't need to take any action. It was a redundant system that had failed. And so, we're just gonna keep riding this rocket. And then about 2 minutes later, we got a caution this time. And then you're really starting to think, okay, what's wrong with this? What else is wrong with this bird? Can we get a different one? But you're going to orbit at this point. And so that was it, for that first 8 minutes. Those were the only 2 things we had to contend with, and we did safely make it into orbit. Being part of the Hubble family is really special. There's this huge group of folks on Earth that that own this telescope. This is their baby, and they've been working on it for decades. And the folks that do the research, worldwide, people use this instrument to do research. And we say that we're helping to unlock the mysteries of the universe. So it's really special to be a part of this team. And the really complicated spacewalks that were planned out, 5 spacewalks back to back to back. It was a tremendous amount of work, and flying the robotic arm, not nearly as physically demanding as what the spacewalkers are doing. And so, the moment they come in the door, you're helping to break down their suits and their equipment and get ready for the next day. So it was just this tremendous rush of activity for really 11 days until we were ready to let the telescope go and come home again. Then we had a couple of weather days, actually, which was kind of nice because we didn't have any more work to do, and we could watch the world go by for a while. But yeah, it was an incredible experience. So the shuttle mission, with the level of intensity and even the way you train, is much more like a sprint. And then the space station mission, with its, the length of it and the variety of different things you're doing, and again, the style of training, it's much more like a marathon. And so your mindset has to be very different. It's not just, hey, I can put up with anything, lack of sleep, lack of food until I get through the other side. You have to take care of yourself. You have to look out for your crewmates. You have to, keep those lines of communication really well with, the home front, and focus kind of on a much further point in the distance than I just have to gut it out for a couple of weeks. So it really is a very different approach in almost every way. So since I got back from my shuttle mission, one of the first roles that I had actually was to be the astronaut representative to the commercial cargo activity that was happening at the time. So I got to work with SpaceX very early on, and I was the Capcom for their first cargo mission to the International Space Station, which was tremendous. Seeing all of that unfold, and then seeing how far we've come now with launching people. I have also been what we call a branch chief in the astronaut office, so taking care of the folks that are training and getting ready to fly, but not actually currently assigned to a mission. I have also been the deputy chief astronaut right before I got this mission assignment. So I've had a lot of great opportunities to learn from other people and other experienced astronauts in our office. I think coming home from a shuttle mission when we knew it was the end of a shuttle program, that was very bittersweet. The shuttle mission was amazing, and I knew that I wasn't ever going to do that again. And we had accomplished so much with the space shuttle, not just, of course, the Hubble Space Telescope, but building the entire International Space Station. So it was hard to see that go. But I have also had the privilege of being here kind of at the start of all these other programs. And when you look at how many programs we have going on right now, it's amazing. So, we kind of touched on, there was the commercial cargo program early on for the International Space Station. And now, of course, we have commercial crew, but we also have the Artemis program and all of the programs that are associated with that, the human lander system, everything that goes along with that. And that's just human space flight. So NASA, across the board, just landing Perseverance on the surface of Mars and about to launch a helicopter. It's just amazing. I'm always, you never get tired of it here. There's just always something new and amazing on the horizon. It's interesting because Shane and I have both been here for a long time, but we have never had either a working or mission assignment together before. So this is the first time that we've really worked together for a lot of time, and it has been so much fun. The kind of the downside of training right now during this COVID pandemic is that we don't get to spend as much time with one another's families, socializing the way we would, I would say, normally do. But Shane and I do spend a lot of time in the simulator together, and when there is downtime in a simulator and you get a chance to share stories, to share experiences. Shane is one of those people that's quiet but very, very funny, and has a lot of great experiences, both family life experiences that he shares with me, as well as Army experiences and his spaceflight experiences. So it's always fun talking with Shane. Aki and I also have been here for a long time together, and we've trained as Capcom together many, many years ago. And I really enjoy spending time with Aki. Somehow, Aki and I have always ended up, we have a rental car together. So we're always driving back and forth when we're in Hawthorne, and we have a lot of time to spend together. And so I really enjoy hearing his stories, from as a Japanese astronaut with JAXA, what was his selection process like? What was his life as an engineer working for JAXA beforehand? And again, we share stories about our family lives. His son is a little bit closer in age to my son, so for me it's a good look into the future, and he always has just insightful comments and wisdom to share with me, which I really appreciate. Thomas is a ball of energy. He is just super lively. He's always the life of the party. He's funny but self-deprecating, and he also, kind of helps expand our worldview. He'll show us different, things that are out there in the internet, and I'll say, "Hey, Thomas, no one's ever heard of that," and he goes, "No, just America has never heard of that." And so it's a good reminder that this is a global effort, that we are an international program, and he represents ESA really well. It is tremendous when you think about all of the different countries that have come together to work on the International Space Station program and the number of years that we have been successfully doing it together. It's really impressive. And that legacy of cooperation across borders, I think, is so powerful. And it's a testament to the fact that, we dream these amazing dreams, we have these huge goals, and we're going to be successful when we work on them together. That's true on an individual level. No individual person gets themselves into space, right? It's a huge effort that happens. But it's also true on this global level, that we have these big dreams where we look out, to the horizon, and this desire to explore the universe around us. And we're always going to be more successful when we work together with our international partners to achieve these incredible dreams. I think for my first flight into space, aboard the space shuttle, I didn't have a complete sense of the size of the effort that's required until I got through the mission, and you see the whole process. Because we train at the Johnson Space Center, and of course Mission Control is here at the Johnson Space Center, and I have been a part of that. But then you go down to the Cape and you see where the vehicle is processed, and you see all of the people that are there that launch you safely into space. And then for the Hubble mission, there's the entire Goddard Space Flight Center that is operating that telescope. And then there's the Space Telescope Science Institute that manages the science part of the program. So that was just for the Hubble Space Telescope mission. And when you think about the International Space Station and the size of that vehicle and the breadth of science that gets accomplished on that vehicle with all of the different countries that are participating, laboratories from Japan, from the European Space Agency, from the United States, so that's taking Hubble times however many that is, right? All of those people that are required to make all of those projects and systems successful. And then now we've added commercial partners to that process, where they have a vehicle that we are using to get us to our space laboratory, and they have all of their design, build, test, operate, launch, all of that process. And so all of those complicated things coming together, blending together, working together in concert to get us up to the International Space Station and be successful in achieving the mission of exploration that we're doing. There's never a single minute that you spend in space where you think that you're by yourself or that you accomplished this by yourself. You're standing on the shoulders of all of the people that have given their life's effort to make this possible. So it's a tremendous honor and it's a tremendous responsibility.